All right, that was fun. Thank you for joining us today. We'll get going now, so we've got a few more people have joined us. Looks like from our poll that we've got a pretty split audience here, but somewhere in the kind of in between the 300 to 500, so we'll call it $400 range is the approximate cost of downtime whenever you have a service-related issue on the road. But let's get going. Like I said, my name is Kyle Friedel, and I work for Interstate Batteries and our sales support teams. And I'm basically here to ask the stupid questions of our experts, Mr. Jeff Barron and Gale Kimbrough. We had some technical issues, so hopefully we're going to have Gale joining us a little bit later. But Jeff, how are you doing today?
Man, if I were any better, I'd be twins.
That's nice. I don't know if we can handle twins of you, but that would be actually, we could really use twins of you. That would be really, really helpful. Jeff and Gale together have almost 100 years of combined experience with automotive and batteries. They have been with Interstate for a collective half of that time and literally wrote the book called the Proclinic Manual on Batteries for Automotive and Commercial Applications. We asked that poll question. We looked at the results. Every time that happens, we're going to just say $400 for a nice round number. That's why as Interstate, if we are your battery provider, it's critical that we do all we can to make sure that those breakdowns or non-starts are not related to batteries. A big part of that is on us. That's giving you the best and freshest batteries. And a big part of that is on you and us. And that's working together as a partnership to make sure that we have the exact right battery for your specifications, for the way you run your fleet and where you run it, how often. There's lots to consider in there, and we'll talk about that. And then lastly, your part is keeping those batteries maintained so that they're going to last every mile that they possibly can. We'll talk about that as well, too. First, we're going to jump into some industry insights, and then we'll jump into getting the most out of those batteries. As most of you know, and you hear every day on the news, the capacity crisis due to COVID, and really, long after the original crunch, is still affecting the industry. And this industry has never seen a wider variety of challenges. It's almost cliche to talk about driver shortages now, but it's very real. Tech shortages. There's a huge gap in the industry that, is not going to be filled or shows no signs of being filled. And, we know it's a crunch for you. The cargo bottlenecks happening in the ports, many supply chain issues that you're experiencing that keep you from getting the parts you need. Microchips, obviously, that's a big one that's been playing out. That photo that you see is Kentucky Motor Speedway. It's full of Ford F-150s waiting on two little microchips in order to be usable as vehicles. So that's been huge everywhere, getting computers, phones, anything. But another big issue coming up is a shortage of lithium batteries and lead acid batteries. Mostly lithium. That's a huge supply constraint on the EV electric vehicles, but lead battery acids due to lead supply, as well as battery components, have caused supply issues across the battery industry. Interstate, however, is more optimized, or I guess we're in a good position to minimize impact, especially during the peak winter demand. We've done a pretty good job of building some safety stock, over 1 million units in our regional distribution centers. We do have a more diversified supply chain than, say, a battery provider that is a manufacturer or works with one manufacturer. We have a little more diversity there. And while we have that diversity, the other thing we do, because we work with other providers, is we want to triple test all the products that we offer, or each product line, I should say. Jeff, that's what you do. That's the majority of your day when you're not answering customer service calls or doing recommendations for fleets. You are testing out these products. So tell us a little bit about what you look for in the batteries that we carry.
Well, so thank you, Kyle, for that. And, we look at the manufacturer's specs, of course. We also look at our competitors out there to see where we've got leverage at as far as what we do. And, we do independent third-party lab testing as well. So we'll actually send what we call sister samples out to an independent lab. So we'll send half to them. We'll do half here. And we're going to actually look at the standard deviations where we actually are doing the same exact test to the same exact protocol. And then we'll look at those numbers to make sure that we're both doing the same thing correctly with the test standards. Our lab is a ISO IEC accredited testing lab. We're 17025, which is all about testing. So we're just like the independent labs, only when we're doing our product here, we're not charging anybody. Well, in a sense of charging, we're charging batteries, but not charging to do the test. We've got to make sure that the specs that we actually have on our batteries are what they're supposed to be, and actually meeting or exceeding is what we're looking for. So we'll do compliance testing, which is your CCA or your reserve capacity or ampere hour testing. We also do a lot of high temperature cycle life testing. So what that means is we're going to actually put a battery in a water bath, and we're going to bring that temperature up to anywhere from 122 degrees or up to 167 degrees to make sure that these things can actually function in an application that's high temperature related. After we do all these tests, so we'll take them from basically cradle to grave. And once they fail on the test, we actually have what we call an autopsy room here. So we'll do teardowns just to kind of see what the failure mode was. And if they went for a extended long period of time, that's a huge plus for us. So we want to know exactly what the probable cause of failure is. And we actually, log all this data as well. So we do quite a bit of, we would call it triple testing, just like you said, Kyle. We've just got to make sure that our product that we sell to you guys is subpar over everybody else. That's what we've got to make sure of. So that's where the triple testing comes in.
All right. Yeah, the teardown test is my favorite part because you get to run a battery through a bandsaw. Yeah. So we want to make sure you have every mile that you can. You pull every mile out of that battery. Jeff, what is the number one question that you get as when you're not testing and you're answering customer service calls? What's the number one question you get?
Well, the number one question I always get is, can I set my battery on the concrete? Is it going to drain my battery down?
Oh, come on. Yes, we do have that come up in every webinar. And the answer is you can set a battery on concrete. It's not the same plastic that it used to be. It's not going to drain the battery. But what's the other number one question that you get?
So the other number one question is,
you here.
Why do my batteries not last longer?
Yeah.
That's the whole key. And as we look at batteries in general, a group size 31 is a group size 31, no matter how you look at it. But you've got to make sure you got the right battery. So for the right application. So 9 times out of 10, it's the wrong battery for the application. Mm-hmm. Also, you can deal with old or non-rotated inventory. Now, that's one of the things that Interstate has always strived for, is being the best battery and the freshest battery on your rack. So look at that. If you've got a supplier that doesn't do rotations as far as coming out and taking the battery and recharging it back up, to 100%, make sure you kind of hit them up about that. Also, you've got to remember, when you're driving down the road, the alternator is not really a charger. Okay. So inadequate recharging on the road, that can actually ruin batteries as well. You've got a lot of new trucks out there that actually have the what we call the remote sense lead, that we can actually make sure the voltage is getting to the battery. So we'll talk about that as we go through here as well. And then the biggest thing is maintenance and your best practices. When you guys are doing PMs, are you actually checking the battery just to make sure that they're still good? So we're going to talk about a lot of this to keep you guys up to speed on everything you should be doing. And maybe you are. We're just going to double check you.
Yeah, and you might find some ideas here that'll help. Some of this is a little bit basic, Jeff. Starts with the.
So as we look, the batteries are there, and why didn't you get more out of the batteries? Why am I having to replace batteries every 2 years or every year and a half? You never know. So you've got to remember, you've got your starting batteries. And so once this truck actually gets started up, now you've got, typically you have a second bank of batteries, and that's your auxiliary batteries. So these are still getting cycled like crazy. So you've got to remember that you've got alternators that are, powering more and more accessory loads, along with the APUs, your computers, your telematics, AC, TVs, whatever you've got in there. We call those creature features. That's what they are. But you've also got states now that are no idle laws. So guess what? You're going to be drawing more with less charging going on.
Yeah, and you might have more frequent.
I'm sorry, Kyle.
You might have more frequent stops.
Oh, yeah.
So
And,
more deliveries, things
because
like that.
a lot of the truck, industry now has said, if you're parking to deliver, you can't leave the truck running. So
Yep.
that's where it all comes in. You're still drawing from these batteries. Keep in mind also when you've got lift gates or, you've got long runs of wires before it gets to the battery, you got a voltage drop there. So this is where you could probably think about a DC to DC converter to be able to help you out on getting some charge back to those batteries. But in reality, what we look at here is all of these high demands on the batteries with inadequate charging. So now you're bringing that battery down to a depth of discharge that most batteries don't like. So what that entails is now you're going to have shorter battery life, and the more expense is going to be, I got to go buy more batteries. Now, keep in mind, with Interstate, we don't mind that because that's selling product. But for you guys, this is a way of life, and you definitely don't want to get stranded out there because of a bad battery or weak batteries.
Right. Now, when you look at making fleet recommendations, that's a big part of your job.
Yes.
We've got a slide for this, but talk about the different things that you look at when you're making an accurate recommendation on this, specifically on the type of battery, the exact part number they should use.
Oh yeah, exactly. So you want to make sure that if you're driving dock to dock and it's just, I'm taking a load here and I'm bringing a load back. So you're just dock jumping is what we would call it. So you don't necessarily need a accessory load battery. So not like an extreme cycle life battery like we have in the 31 ECL. So you've got to look at what demands have I got on the starting side? Am I doing a lot of cycling? So if I got an APU unit back there that I've got, everything under the sun because I live in this thing for, 250 days a year. So how much load do I have there? Also, where and how am I driving? Am I going up a lot of northern areas where I'm in the, up there in the cold during the winter? Or do I do a lot of long runs in the southern states where it's really, really hot? And then you've also got to take into consideration the charging time. So you guys are allotted X amount of hours to be on the road driving just due to the DOT regulations. So you've got to factor in all these different things along with what's your factory specifications for, number one, the battery, and number two, the charging side of it. And then we look at all the other accessory loads. So, if you're a dump truck driver or, just a parts driver, we've got to know all these different things. And that's one of the reasons why we do a lot of training with our route sales managers, because if they're looking at accounts and looking at your account in particular, we want to know what you're using these batteries for. The more we know about your account and how you perform all these drive times, the better off we're going to be able to tell you what battery is going to work best with your application. You can't mix flooded product with AGM product and make them all last the same. So we want to make sure that we're actually getting this information from your guys, whether it's your salesperson or, your fleet manager. We need to know all these different things so we can actually get you the right battery in your application. That's what it's all about.
Yeah. And
go ahead, Kyle.
I was going to say, I'll let you take a breath. As we know, it breaks down into two types of batteries, your starting or cycling or auxiliary batteries. Let's jump into starting, but we can go through this kind of quickly because starting batteries aren't really doing the heaviest work.
No, starting batteries are there, to basically start up the engine. That's what it's there for. I mean, once you've got it started up, the alternator's taken over. So now it's going to take care of all the electrical loads. So you're not really taking a whole lot out of that battery. Now, keep in mind, your vehicle does have an OE specification for CCA. You want to make sure that you hit that CCA value. So we always say, whatever the specs are, you can actually go 10% over and you're not going to kill it, because you can do an overkill on a battery. Yeah. And then it's not using its full potential. So you can actually have some of those be premature failures, and we don't want that.
Yeah. And I know the big, the thing I would hear a few years ago is everybody just wanted the biggest CCA battery they could get, but that can actually cost them a lot of cycle time.
Yes, sir. And that's never a good thing. So starting batteries, I mean, they're designed to basically crank up. And then after you get it cranked up, the ignition, everything is taken over, the alternator's running, taking care of all the electrical loads. So you've got to make sure that you do have a dedicated cycling battery if you have these APUs or excessive accessory loads on. So starting batteries, great. Make sure you got some actual cycling batteries lined up for these APU applications. That's the whole key behind it. Now, starting batteries, I'll do that real quick, Kyle. So starting batteries, you're only taking out 3 to 40% whenever you're cranking up. That's it. Duty cycles on a typical 31 battery is about 25% depth of discharge that you would actually run. And that's a high stringent test that we can actually run here in our high temperature cycle life testing, just so you guys are aware of that.
All right. Want to jump in on cycling?
I sure will. So make sure you start with the right battery. So you don't want a starting battery if you're going to be running lift gates, because these batteries will cycle out in a matter of 20 to 30 times, and that's it. So you don't want to use that as a cycling battery. If it's a cranking battery only, that's what you use it for. All right. So these cycling batteries, now they're powering more accessory loads, so they're actually getting a little bit deeper depth of discharge, which some of these batteries like that, like lift gates, heavier loads, sleepers in the cabins and all these things really like to be discharged and then recharged efficiently. Now, the efficiency side of it's where all this comes back into play. We've got to make sure that we are getting these things fully charged back up.
You say they like to be discharged, but what really that means, you still wouldn't recommend more than a 50%?
Oh, no. We kind of look back at the true deep cycle in flooded and even seal lead acid batteries. 50% depth of discharge is what we recommend. And the reason behind that, the lower you get on the depth of discharge, the more resistance you create when you go back into charging. And you guys are pretty much aware of what resistance creates. It creates heat. And that will tear up a battery in no time.
All right.
And then you got to have adequate time to recharge. I know we've got all these no idle laws. You've got, more stops and shorter charge times in between. You've also got the voltage drops that are, occurring between, 20 or 30 foot of cable. So you got to keep these things in mind as well. And we've got to figure out a way to get these batteries fully charged back up. That's the whole key and takeaway on this.
So the challenge of that is just considering your environment. You're not idling or driving enough, taking too many or a lot more stops and starts, voltage drops. And what about I'd heard a new term, ultra capacitors that are being added for starting capability.
Yeah, and this is one thing that we struggle with. I say I get calls weekly, and it's usually 1 to 2 times a week that I get a call about using an ultra capacitor. Ultra capacitors are fine because they do give you that output of energy really quick. But what folks don't understand is, they're taking out one of these group size 31s, and let's say you had 4 of them in there. Well, yeah, you've got great starting capacity there because of that huge ultra capacitor, but you've lost on the reserve capacity side or ampere hour side. So we're not discounting ultra capacitors. We're just saying that if you are going to energize one of those in your system, don't take out a battery to replace that with. I mean, I know the marketing people are out there doing this, saying, yeah, you can replace one of them and this is your ultra capacitor. You guys got to look on the other side of the coin now, because as you're looking at no idle laws, you still need capacity. The capacitor itself, the ultra capacitor, is designed to output a very high amperage load for a short duration. So that's what you've got to watch out for.
And basic rule of thumb, deeper average depth of discharge, like really below 50%.
Yes.
With inadequate charging time leads to premature failure.
In premature failure. That's exactly right.
All right. And AGM, this comes up in every webinar. It's still a bit of a mystery, it seems. We know that there are pure lead AGMs, that's virgin lead. It hasn't been used before. Is alloy AGM, is that a mix with other metals, or is it just recycled lead?
It's just recycled lead, which if you look at pure lead and you look at alloyed lead, when you look at lifespans, your pure lead is definitely going to last longer. There's no question there. That's why you'll see the price is just a little bit higher as well. But you've got a lot more frequent uses with these things as well. So that's the key. You know.
And you can charge faster. So that's good if you've got a delivery truck or you're making short hauls, right?
Yeah,
You're worried about
exactly.
charging time.
Yep. Now they don't mind a little bit deeper discharge. I'm going to throw that out there as well, but the charge has got to be done appropriately as well.
Deeper than what?
Well, what we say is you don't want to go any lower than 50%. Either way you look at it, because that way you get a more efficient recharge coming back in, and that's where it's all at. Once again, we're going to talk about charging throughout this whole thing, and the keys behind making a battery last is making it happy with a recharge.
Okay. Yeah, we'll talk more about charging on AGMs later.
Yes.
And the other benefit, I mean, these were made for submarines and off-road vehicles at first, right?
So the Pure Lead product, Kyle, actually got started with the the submarines, tanks. It was all done for the military because they needed to be able to rely on a battery, and especially under fire, no pun intended there, to be able to make sure that they're going to be able to get out.
Right.
All right. So the cranking up has got to be there. And so, yes, they're more vibration resistant. Most of these are all anchor bonded as well. So there's an epoxy agent that's actually put in the bottom of the battery before they insert all the plates. So they are designed to handle a lot of vibration. And especially if you're in the off-roads or, doing a lot of construction sites and all, that's where that vibration resistance is going to come in, because keep in mind, they're sitting on a platform, typically a metal platform, and the diesel truck is vibrating itself. So there's a lot of vibration going on there. Awesome. This is where that comes into play and makes them last.
Yeah. All right. So we've talked about having, starting and cycling and AGMs, and we talk about having the exact right part within those, within your starting batteries and within your cycling batteries. We're going to go to a customer story. Chris DeSantis is a purchasing and training president or vice president for AIM Leasing, the largest fleet in Corcentric's in the Corcentric buying group. He's also on the board of directors for TMC and is chairman of an S1 electrical study group. So he also wrote the book on electrical systems and batteries. He knows his stuff. Started as a technician. Formerly, he was a fleet service manager.
What we ran into a couple years ago, and I'm sure everybody else did too, when we got into the.
We just let him share his story, and then I'll come back in.
What we ran into a couple years ago, and I'm sure everybody else did too, when we got into the no idling laws, with more of our city delivery operations, food service operations, and liftgate style operations, we were running into more frequent breakdowns because the trucks were not idling anymore, keeping the batteries charged up. We're seeing shortened battery life because of that also. And we needed to come up with a solution for it. And working with Interstate, we came up with a good battery that would make that fit the 31 ECL due to its cycle life and having so many cycles available in the battery, but it also does reduce the cold cranking amps of the battery. And it was a tough process to get through with the purchasing department because, acquisition cost was higher for the ECL versus the battery we were using. So we needed to get something, discussed with the purchasing department. It took about 2 years to get over that upfront cost versus the total life cycle cost of that battery. So once we got past that hurdle, and it was probably, the hurdle probably came from the multiple breakdowns and customer complaints that we were able to get past that hurdle. Immediately, we started to see a reduced breakdown cost, which you just can't measure, how much cost savings that is, versus the purchase price of the battery. We almost doubled our battery life in the stop and go operating customers that were using lift gates. And the good part about that conversion and part of the results of that conversion are, since the conversion, we really don't talk about batteries anymore because the battery we chose is performing as we set it up and as it was designed. Now that I'm sitting back in purchasing and coming from a technical background and being involved with the TMC and everything, we can make these kind of decisions a little bit faster now that we know the life cycle costs, and our ROI is very quick on the changeover for this type of item.
So what I love about that story is he started as a fleet service manager, and he was battling the purchasing director, and now he's in purchasing, and they don't even think about batteries now. He thinks about the total cost of the life of that battery or the life of that fleet, right? He's thinking in terms of 6-10 years instead of how long is this one battery going to last. So be thinking, is it worth spending a little bit more? And we'll talk a little bit in a minute about why you might spend a little bit more, but it is worth spending a little bit more for a battery that's going to give you 2 times the cycle life, versus the cost of one breakdown. As we talked about, $400 for a single breakdown. If you can avoid that breakdown, that's the difference in an inexpensive battery versus maybe a more expensive one. So that's something we want to help provide to you for our dealers. And if you're not one of our dealers, we'll work with you on that too. We want to look at your fleet and help you make the best decision. See if you already have the best battery for what you're doing. So if we were doing that, we would look at your starting and cycling batteries, want to know what you're driving as far as the OE specifications for batteries and alternators. How are you driving it? Are you long haul, regional delivery? What's the climate like as far as weather, cold temperatures, and also regulations in your area, and what equipment you've got on there, accessories and things like that. And any additional charging equipment, we would ask about that, sense leads, DC-DC converters. Just really understand the program that you have to see if we could maybe save you some money in the long run with a better battery. Jeff, we got a surprise visitor.
We do?
Surprised you actually made it onto the call.
Gale did?
Mr. Battery himself.
Hey,
Gale Kimbrough is on the call.
Gale.
Hopefully
hey guys,
Hey,
thank
there he
you.
is.
Thank you very much for allowing me to get on. I guess I had a little technical difficulty, and I don't advise this, but if you take a hammer and hit that computer well enough at the right place, you get back on.
Awesome. That's good IT. That's good IT best practices there.
Exactly. That's
Well, Gale, you're just in time to talk about, we've been talking about the right battery as far as specifications for starting and cycling and AGM, and talking about the way they use their battery. But now that you got the right battery specified, you want to make sure that you're getting the freshest in the inventory. And not everybody knows this. In fact, I learned something on this week. So talk to us about getting the freshest inventory.
as you know, Kyle and Jeff, it is so important to have a fresh battery, because batteries are very much like similar to milk that you purchase or bread. It deteriorates if you don't utilize it and or keep it refrigerated in that case, or in our situation, keep it fresh. And so date codes come with the battery in a situation directly from the factory, as we're seeing this alphanumeric code FOOCD. I would try to pronounce that, but I think I'm going to go with the F as the month, and that would be obviously June. We go A, B, C, D, E, F. So that would be all the way through I, or L actually. And then the second digit is the year. So obviously this battery is June of 2020. And so what are you looking for in this type situation? You're looking for freshness guaranteed. One of the things that Interstate Batteries created and refined over the many 70 years of being in the battery business is refined a freshness guaranteed capability. We rotate the stock, and so you shouldn't allow the batteries to be on the shelf more than a few months. 3 to 4 months is optimum. But anyway, the longer you allow that battery to sit on the shelf and not be used, that's setting on the shelf and to some degree, not deteriorating, but at least losing power or capacity or voltage or state of charge. Some of those date dots that you see on the batteries on the top are more to let you know for a warranty purpose rather than the actual date code that comes from the factory. And so again, we try to, at Interstate, we have a program to where we try to rotate those batteries every 3 or 4 months. The reason for that, obviously, is discharge capability of a battery. You lose or discharge somewhere at 80 degrees Fahrenheit or 26.7 degrees Celsius. You lose a certain amount of power or voltage state of charge every month, somewhere 5 to 7%. Now that's a little less on an AGM than it is on a flooded lead acid, but this chart, for example, this what we call self-discharge is faster at higher temperatures and at lower temperatures slower because of the electrolyte and because it slows down that chemical process. So in that situation, you can see from this chart, it's going to vary depending upon which cold or it's hot. So at these higher temperatures, it's going to deteriorate faster. I had a situation where I came into a shop and they had the battery sitting on a rack at the window on the west side, and the sun was coming down on that battery rack and the batteries every day, every afternoon, and it was making the batteries be at a higher temperature every single day, and therefore the batteries were going to a lower voltage than they would have if they'd have put them away from that window. Just minor detail. One of the other things that happens as it deteriorates, as it discharges, I should say, when it gets to a certain level, for example, about 25–30% discharge, there is a sulfation characteristic. If you look at the bottom picture, that white is indicative of sulfate, and that sulfate is not usable energy that you need to use, so it cannot be removed by the alternator or trickle charging. It has to be removed by something, by a charger externally or something that's going to go to a higher voltage level to take that sulfate off that plate and be more usable energy that you need. Because once you get to that 30%, you continue to allow that battery to sit, you've deteriorated or taken away some of the battery power and capacity in that situation. So you don't want sulfation taking over that battery in there. You don't want it sitting on the shelf.
Yeah. So this is why we need to have the freshest batteries in there. And if we bring you, or anybody brings you, a fresh battery, it does still need to be taken out and recharged every 3 to 4 months to shake that sulfation off. This one is probably beyond saving. And that photo is actually from it's an automotive battery, but it's one that was, the one on the left was not rotated. It's a competitor's battery, was not rotated, and it's 11 months old. And the one on the right is an Interstate battery that was rotated, and it's actually 13 months old. This is one of the ones we ran through the bandsaw. You can see a little bit of sulfation on the Interstate battery, but it's actually a 2-month older battery, but it tested just like within the parameters of a new battery. So that rotation is important to keeping that battery fresh. But even after a year, if that battery has not been used or sold, Interstate's going to take that out of new battery inventory. So even though it still runs as good as new. But then
I'm sorry, I didn't mean to cut in, but our warehouses have dedicated equipment to make sure that they can get the sulfate off.
Yeah. So yeah, and then one more thing. One non-rotated battery can bring down a pack of newer batteries, right?
You're correct. Absolutely right, because it's going to go toward the lowest one and trying to average the battery voltage across the entire pack because it's connected in parallel. So if you have a non-rotated battery that's sulfated like that, guess what? It's going to hurt the entire system.
Yeah. So just as a summary of that, go back, check your batteries. If you're working with Interstate, the date sticker should not be more than 3 or 4 months old here. And this is how you can read your manufacturing dates. And if you're not working with Interstate, well, I'd like to say you should be, but that's not what we're doing here.
Why aren't you?
Yeah. Let's talk about preventative maintenance and best practices there. We talked about having the right battery, the freshest battery, now knowing the condition of the batteries you have.
Thank you, Kyle. Yeah, so we're going to talk about the pulse conductance tester that we actually have out there. It's a quick and easy tool to use. You can actually do pack testing now as well. And so we want to make sure that, when you're doing your typical PMs, that you're looking at everything, test. And what we've always said, and Kyle loves this one, is You test the lead, not the thread, because we've got a lot of folks that'll actually connect the connectors to the studs. Well, you got to remember that's an inverted bolt that's actually welded into that lead pad, and it's only there as a tightening point for your eyelet connectors on your cables. That's it.
That's to keep it connected to the lead.
To the lead, exactly. So that's why we've always said test the lead, not the thread.
You didn't always say that.
Gale,
we just made that up the other day.
Yeah, Gale and I've actually encountered this on multiple occasions where we'll get an account that calls the distributor. Distributor calls us because they're testing their batteries and they're falling way lower than what the specs are. And so we've made several trips, unfortunately, out to locations, and we find out their process is connecting it to the stud.
Mm.
Well. We got a nice trip out of it, though, right, Gale?
Exactly. Hey, one of the other things that I've seen, and you've seen also, Jeff, is that they test them before they're actually a battery that's put on the vehicle. And we don't recommend these types of testers, conductance testers, because conductance testers were made for batteries in service.
Not new.
Not brand new, that haven't been used.
All right. We are going to need to pick up our pace a little bit if we're going to finish on time. But right now, we don't have many questions to answer. So if you have a question, just a reminder, you can open the toolbar in Zoom and type your question into the Q&A section, and we will try to get to those at the end of the webinar. So quarterly pack testing,
yes.
At
individual
regular
battery
PM.
testing as well during your quarterly test. Check the voltages. If they're below 12.6 to 12.5, that requires charging. And one thing we've always said, never add a new battery to an old pack, like Gale was talking about earlier. We don't want to do that, because what that does is it takes that brand new battery and it's going to equalize to the old pack. So we don't want to mix batteries, period.
So we don't want to throw away batteries either. Those are expensive.
Exactly.
Can you add a battery that's a similar age to a pack?
Well, we don't recommend doing it by age. And the reason behind that is you don't know how that battery was actually used within that time period. So what we look for is kind of like voltages and capacities. So, if they're coming in at 670 and the other one's coming in at, 950, don't mix those together. So kind of bring these together to where they're even and they're going to work nice together. So it's not necessarily about an age.
Okay. And one other question, I see, can the pulse tester test the charging system like it can in an automotive application?
Well, it'll check voltage. It's not going to test a whole lot of amperage. There's no amp clamp with it. So it's going to give you a system test with voltage for sure.
Okay. And then charging batteries. Let's get into that.
We got to learn how to charge batteries all over again, right? Alternators are just there to basically take care of the electrical loads when that vehicle is running. So it's not a true charger like we discussed in the beginning. So, if the batteries get down below a 25% depth of discharge, you are not going to get those things charged up unless you're driving for days. And I don't think anybody wants to do that.
Right.
So we've got to make sure that we keep our batteries, where they need to be, so they're going to operate when we need them to operate. We're going to talk about some of the charging scenarios in here. And I think, Kyle, you've got a video that we're going to talk about.
Here we go.
Okay, folks, let's talk about how to hook up these batteries to charge them efficiently. So we've got 4 group size 31 batteries here that we've actually got connected in parallel. So all of your positive cables are hooked together for the positive terminals. And we've got all of our negative cables connected to the negative terminal on all 4 batteries. So let's discuss how we're actually going to charge these batteries to make it efficient. Now I've taken the negative charger lead and I've hooked it onto, let's say this is battery number 4. So I've hooked up the negative lead to battery number 4, and I've actually attached the positive charging cable to, let's say this is battery number 1. So now I've got 1, 2, 3, 4 batteries connected in parallel, and now my charger is going to see this as one big battery and charge all 4 batteries at the same time. Now let's talk about the wrong way to hook up a charger. We've got a lot of folks that will actually hook the charger up like this, where you've got the positive on battery number 1 and the negative on battery number 1. Now you got 3 other batteries that this thing is going to have to try to fill up. This is the incorrect way.
All right.
Man, that guy's got a good voice, don't he?
Yeah, face for radio, but
Yeah, that face has got to go.
that's why we're not on camera.
Absolutely. I join that, by the way.
So Gale, talk to us about charging stages.
Okay. Well, one of the things about smart chargers that are different than your alternator, again, your alternator is a maintainer. It's not there to recharge the batteries. Its primary function is to run all the accessories on that vehicle, not to charge your batteries. It's a maintainer more than is anything else. So we have multiple stage chargers. And so in this situation, we're illustrating a 4-stage charger here that has a bulk stage. Then that will be bringing in bulk current into the battery that may bring it up to 75% state of charge. Then it goes into an absorption. That means that the regulation of the voltage has reached its peak and now it's stabilizing. And so you have an absorption stage, and that's going to bring in another 5 to 10% of the battery capacity that is trying to get back to a full state of charge. Then we go into a finished charge, which is upping the voltage level and bringing in a finished stage to bring that battery up, obviously very close to 100% state of charge. And then the float or maintenance charge is just something there to maintain the battery at 97 to 100% state of charge. It's not there to bulk charge it. It's just there to maintain. So these 4-stage, 5-stage chargers you find in the marketplace today that are very good for charging inside your fleet.
All right. And Jeff, take us through a little bit more on charging specifically with AGMs.
Oh, you got it. So we got a lot of shops out there that actually have they've either got a series charger or they got a parallel charger. And so what we really like using, and especially in the shop, is using a charger that is designed for AGM. The reason behind that is flooded product can actually have charging voltages that will exceed 17 volts. AGM batteries will not like that. So make sure that you've got a charger that is designed for AGM. So when you're looking at that, follow the normal charging procedures and be careful with them. If you've got a shorted cell, it doesn't matter whether it's a flooded battery or an AGM battery, there are chances that this thing could come apart. We call it rapid disassembly. So when you're using these chargers, and Gale and I've seen this over and over again, where they've actually got the leads hooked up onto the studs. Once again, use the lead, not the thread. So we want to make sure that you're connecting these properly. We do offer lead adapters, and a lot of the other battery suppliers do as well, to screw down on there to keep that lead on lead contact. So make sure you're using the right connectors and all when you're doing this. Onboard or alternator charging for AGM or flooded, you've got to make sure, because as you're seeing new model trucks come out, some of these are designed to work with AGM product, not flooded. So we've got to make sure that if you are replacing the OE batteries, know exactly what they are, because that way you're going to know if that charger, and some of these now are getting computer controlled as well. So that's where you throw in another kink in the system as well. You've got to know what the OE alternator is going to be outputting to make sure it's actually going to work with either the flooded or the AGM product. Also look at your wires. Keep in mind that you can actually have a 0.5 volt drop from the alternator to the battery itself. And as you go further and further back onto the trailer, you could have even more voltage drops. So that's where the DC to DC converters will come in and compensate for that voltage drop. We've got to make sure that we're keeping these things as charged as we can, because that's your livelihood when you're out there. And especially if you're doing no idle laws and you have to stop, you want to make sure that that next day or those few hours down the road that you're going to be able to crank it up and be able to go.
All right. And we had another poll question. I think I was supposed to ask it a little bit earlier, but John, if you wouldn't mind, could we pop that one up? Just simply wanted to ask you how frequently you are seeing battery related breakdowns with your fleet. How frequently does your fleet experience battery related breakdowns on the road?
Well, that would be using your feet.
Yeah, you'd be like Fred Flintstone out there trying to move a truck down the road. Yeah, give everybody a second to look at that. We're going to go into a few more preventative maintenance tips, and some of them, they sound basic, but I'm pretty sure these come up pretty frequently. And
yes, sir, they do.
Yeah, talk about these if you would.
Yeah,
Jeff.
So don't overlook the basics. If you've got corrosion on any of these cables, please neutralize it. Simple baking soda and water can actually do this, where it neutralizes all of the corrosion that's on there. And a wire brush is not going to do it all. We got a lot of folks that's what they do. We've also got what we call the wicking effect, and our picture over here on the right will kind of show that. So corrosion can actually migrate up through the cables, the covers on them. So do your best. I mean, if you've got what looks like heat is actually just kind of deformed the plastic cover around the cable, 9 times out of 10, that's probably corrosion under there. So in a case like that, you're creating more resistance. So, this current needs to have a path where it can actually run. And so when you start cutting off that path, you get a lot of heat, and you don't want to melt down, especially on the pack of batteries that you actually have. So in a case like that, it's best to replace the cable. So once again, you're following through on your regular PM schedules. Once you get that neutralized, if it's just on the cable ends, rinse it off with the distilled water, dry it off completely. And then you want to torque these things back down to the specs that they go for. So once it's all dried off on a 3/8 stud, your torque spec is 120 to 180 inch-pounds. So what that equates to is about 10 to 15 foot-pounds. When you start over torquing, remember I was talking about this being an inverted bolt on that lead pad that's welded in there. You can actually start pulling that thread or the bolt itself up out of that pad. So once you do that, game's over. So once you get everything connected and it's all torqued down to where it needs to be, use a spray protector. That keeps out the moisture, and especially these things are going to be exposed to all that as you're driving down the road. So make sure you actually use that to keep these things protected. Looks like we got our results.
Yeah. So it looks like we're trending a little closer to 3 times a year. If I were to just boil that down, essentially 3 times a year, and we kind of averaged out our costs. That's $1,200 a year in battery breakdowns. So battery related breakdowns. So we want to help you make sure that doesn't happen, and would ask you if you're interested in receiving a consultation on this. Put that in the Q&A. Let us know that you're up for that. You're interested in getting a call. That will be, we'll go through that pretty long checklist, a lot of Q&A for you, but we will ask you if we'll work with you to see if we've got the right battery, or if you've got the right battery. So so once we've done all this, guys, we know we've got the best battery for the application. You have fresh batteries. You've looked at those date codes and you have rotated stock. Your connections are good. You don't see any corrosion, but you're still seeing problems. Gale, can you talk us through just the step-by-step voltage drops, how to check for that?
Yes, it's very important to make sure you know how to check for voltage drops or losses between, for example, if you've got as 14.1 at the B plus of the alternator, what do you want at your batteries? Well, you would like to have 14.1, but obviously that's not going to happen. The reason it's not going to happen is because you've got cable length and there's resistance per individual or linear length of the cable. And so that brings down the voltage getting to your batteries. If you're running AGM, you can't afford to have 13.8 or 13.9 at that battery. What'll happen, you'll have a great AGM battery, but it won't stay charged. In fact, you won't get but about 65% of its capability capacity if you run it that low at the battery itself. So you got to make sure you have the correct or have the adequate voltage level. And so that voltage drop on post, you can check them. In fact, we have a way of of illustrating that, and so you can get with us and we can talk a great deal about voltage drops on post cables and cables to ground, cables, positive cables, etc., and the corrosion factor. So freshness is so important, as we talked about earlier, but so are the things like voltage drops. Don't make sure that you're testing the voltage loss between point A and point B when you're starting and or when you're checking your voltage at the battery versus the alternator, etc. Or if you're running lift gates, that's a big voltage drop, 5/6 of a volt from the alternator. So make sure you know what you're doing and get a step-by-step check step-by-step for voltage drops on post cables and connections. Okay.
All right. After that, it's probably time to start looking at the accessories and seeing what that problem might be there. So
yes,
cool.
Exactly.
All right. As we're about to wrap it up, guys, I want to thank you guys again. And just kind of to summarize, as I mentioned, never faced more challenges. Battery shortages will happen, especially in the peak winter season, but Interstate works with multiple suppliers and triple tests our product. You guys want to take us home and tell us how to get the most, remind us how to get the most out of those batteries?
Yeah, start with the right battery for the right application for sure. Starting, cycling, even the charging time and accessory demands. That's what we want to make sure we've got the right battery in your hands to be able to keep that fleet going.
You're exactly right, Jeff. And let us help you if you need help with that. We have a website there, and make sure that you let us know if you need help. We're here to help you. Jeff works 24/7, 7 days a week, 365. It
kind of feels like it.
Yes, I'm sure it does. But he takes calls all the time and or can get you the proper questions answered that you have, the answers that you need and have. So again, we make sure or want to make sure that the total cost of ownership, not piecemeal, but the total cost of ownership is, as an example, you can buy cheap. Obviously, you can buy different things that are cheaper. That doesn't lead to good ownership, total cost of ownership. Believe me, I have worked with, taught classes. We both taught classes, and we've seen situations where they tried to go cheap and it cost them deep.
That is right. That ain't cheap.
It ain't cheap.
A cheap battery can be very expensive.
Yes.
Exactly. It'll really cost you in that long run, guys. Really.
Yeah, make sure you look at your rotations too. I mean, if your battery supplier is not doing that, look at having a conversation with them. Make sure that they're doing it every 3 to 4 months, and that way they're charging it back up.
You're exactly right, Jeff. And start with the freshest battery. Know your battery's total health. Get the right battery for your application. Make sure it has some cycling characteristics in that battery. Every truck driving down the road needs a starting cycling battery, something that has the capability of being tested to cycle more than 300 times, 300 cycles or more in that situation at 25% depth of discharge, as Jeff probably alluded to earlier.
Yeah, that's our high temperature cycle life testing.
Yes.
Awesome. Well, great stuff, guys. Appreciate everybody who joined us today. Appreciate your time, Jeff and Gale. Thank you very much.
Yeah, sorry for the technical difficulty, guys, in getting in late.
Yeah, no problem. Look for Interstate. Go to interstatebatteries.com/Proclinic. There's more videos and previous webinars, including 1 or 2 others on commercial applications. Next month, actually in January, we'll be running a Proclinic on marine and RV batteries, deep cycle batteries. And then in March, just to let you know, we'll be doing one on equipment, heavy duty industrial equipment batteries. So be on the lookout for invitations to those. We thank you, everybody that joined us. Have a great day.
Thank you all. We appreciate it.
Thank y'all very much.